Before we begin, a brief disclaimer. The information in this presentation is for educational and informational purposes only. It is not intended to be a substitute for professional business, financial, or IT advice. The examples used are illustrative and may not be applicable to your specific situation. Always consult with a qualified professional before making any significant business or architectural decisions. Have you ever worked at a company where it felt like nobody was talking to each other? Where the marketing team launches a massive campaign for a new product, but the sales team has no idea how to sell it, and the IT systems can't even handle the orders? Or maybe you've seen two different departments, sitting 50 feet apart, spend 6 months and $1 million building the exact same software, completely unaware of each other's existence. Feels like chaos. It feels like a colossal waste of time, money, and talent. And most people just shrug and say, well, that's just how big companies are. But what if I told you it's not random? What if I told you that this chaos, this inefficiency, this constant feeling of running in place, is a symptom of a specific identifiable disease? And more importantly, what if I told you there's a cure? A discipline designed specifically to prevent this exact kind of corporate meltdown. It's called enterprise architecture. Now I know what you're thinking. Enterprise architecture. Sounds intimidating. It sounds like something for C-suite executives in glass-walled boardrooms, or for hyper-specialized IT gurus who speak in acronyms. It sounds complex, boring, and completely disconnected from your daily job. I'm here to tell you that's wrong. And over the next 80 minutes, I'm going to prove it. We are going to demystify enterprise architecture completely. We're going to strip away the jargon, toss out the confusing diagrams, and reveal the simple, powerful core idea at its heart. By the end of this video, you won't just understand what enterprise architecture is. You will see your own company, your own career, and the entire business world through a new, much clearer lens. You'll understand the hidden forces that determine whether a company thrives and innovates, or stagnates and fails. Think about Blockbuster Video in the early 2000s. They were a titan. 9,000 stores, a global brand, a dominant force in home entertainment. They had all the money, all the people, all the resources in the world. And then along came a tiny DVD buy mail startup called Netflix. On the surface, the battle was about online streaming versus physical stores. But the real story, the one that happened behind the scenes, was a battle of architecture. Blockbuster was a collection of disconnected pieces. Their stores operated as individual fortresses. Their online service was a completely separate entity that their stores actually saw as a competitor. Their supply chain was built for physical tapes, not a nimble, data-driven subscription model. They were a pile of very expensive, very high-quality bricks with no blueprint. Netflix, on the other hand, was designed from day one. They didn't just build a website, they built a system. They architected a business where customer data from their website informed which DVDs to buy, which influenced their recommendation engine, which drove customer satisfaction, which fueled their subscription growth. Every piece was connected. Every decision was based on a holistic view of the entire enterprise. They didn't just have a better product, they had a better design, a better architecture. And we all know how that story ended. Blockbuster is a trivia question. Netflix is a global empire. That is the power of enterprise architecture. It's the difference between a pile of bricks and a skyscraper. It's the difference between a garage band and a symphony orchestra. So let's break down the name itself because it's actually incredibly simple. First, enterprise. This just means the whole organization, not just the IT department, not just the finance department, all of it. The people, the business processes, the information flowing between them, and the technology that supports it all. The entire enterprise. Second, architecture. This is the key. What does an architect do? An architect doesn't lay bricks. An architect doesn't pour concrete. An architect creates the blueprint, the master plan. They figure out how the plumbing connects to the electrical system, how the foundation supports the walls, and how the overall design will serve the needs of the people who will live and work inside the building. They ensure that all the individual components work together to create something that is functional, efficient, and built to last. An enterprise architect does the exact same thing, but for a business. They are the city planners of the corporate world. Think about it. If you let 1,000 different construction companies build whatever they want, wherever they want, you don't get a city. You get chaos. You get a factory next to a hospital, a highway that leads to a dead end, and 3 different power grids that can't connect to each other. To build a functioning city, you need a plan. You need to know where the residential zones are, where the commercial districts go, how the roads and subways will connect everything, and how the water, power, and data will flow. That city plan is the enterprise architecture. It's the master blueprint that aligns every single part of the business, from the technology it uses to the way its people work, with its overall goals. The goal isn't to control every little decision. The goal is to provide a framework, a set of guardrails and guidelines, so that as the company grows and changes, it does so in a way that is coherent, efficient, and strategic, rather than chaotic and wasteful. Without this blueprint, you get what we talked about at the beginning. You get departments that don't talk to each other. You get redundant, overlapping technology that costs a fortune to maintain. You get business strategies that sound great in a PowerPoint presentation, but that the company is physically incapable of executing, because the underlying systems and processes are a tangled mess. It's like trying to win a Formula One race with a car that has the engine of a lawnmower, the wheels of a bicycle, and the steering wheel of a boat. The parts just don't work together. Most people who work in large organizations feel this pain every single day. They see the inefficiency. They fight with clunky software. They get frustrated by processes that make no sense. They are the highly skilled bricklayers, trying their best to build something great, but they've been given a confusing, contradictory, or non-existent blueprint. They're trying to build a skyscraper on a foundation made of sand. So this video is for them. It's for anyone who wants to understand the why behind the chaos. It's for the project manager who wants to know why their project is always fighting against the grain of the company. It's for the software developer who wants to build things that actually solve business problems, not just create new ones. It's for the business analyst who wants to bridge the gap between what the business wants and what IT can deliver. And it's for the ambitious leader who wants to be the one who can see the whole picture, connect the dots, and steer their organization away from the iceberg and towards success. Our journey over the next 80 minutes will be straightforward. First, we're going to dive deeper into the core problem that EA solves, the fundamental disconnect between business strategy and IT reality. We'll look at why this gap exists in almost every company, and the massive costs associated with it. Then we'll explore the 4 primary domains, the 4 key pillars of enterprise architecture, breaking down exactly what they are in plain English. After that, we'll get practical. We'll look at the most famous EA frameworks like TOGAF and Zachman, not as complex textbooks to be memorized, but as simple toolkits like a set of recipes you can use to cook a great meal. Finally, we'll bring it all to life with real-world case studies, showing you how companies you know have used these principles to innovate, dominate their markets, and save themselves from the brink of collapse. My promise to you is this: no fluff, no impenetrable jargon, just a clear, compelling, and incredibly valuable explanation of one of the most important, but least understood disciplines in the modern world. This is the secret language of successful companies, and it's time you learn how to speak it. To understand this secret language, let's start not with a company, but with a city. Imagine a brand new city, booming and growing at an incredible pace. It began as a small settlement, just a few houses and a general store connected by a single dirt road. But word got out. Opportunity was here. So people started flooding in. New neighborhoods sprang up almost overnight. The problem was each neighborhood was built by a different developer, with a completely different vision. The downtown core, built by a high-tech developer, is all gleaming glass skyscrapers and wide 6-lane boulevards. But right next to it, an old-world developer built a historic district with narrow, winding cobblestone streets that are a nightmare for modern cars. Over on the east side, they use state-of-the-art fiber optic cables for internet, while the west side is still running on ancient copper wires. The plumbing systems are completely incompatible. A pipe from one neighborhood literally can't connect to a pipe in the next. The power grid is a terrifying patchwork of different providers and aging transformers, some dangerously overloaded, threatening blackouts every summer. Getting from one side of this city to the other is an odyssey. There's no unified public transport. There was no central plan, no zoning committee, just chaotic organic growth. This city is inefficient. It's frustrating to live in, and it is incredibly expensive to maintain. This city is what most large companies look like from the inside. The shiny downtown core? That's the sales department. They just spent millions on the latest, greatest cloud-based CRM software. The old historic district? That's the finance department, running on a stable but ancient mainframe system that was coded when the internet was still a science experiment. The manufacturing division is the industrial park on the edge of town, using custom-built software from the 90s that only 2 people in the entire company still know how to operate. Marketing, feeling constrained, just went off and built their own trendy little neighborhood on a completely separate cloud platform, totally disconnected from everyone else. Each department, each corporate neighborhood, solves its own problems in isolation. They buy their own software. They build their own databases. They invent their own processes. On the surface, it looks like progress. They feel agile. They feel independent. But what they're actually creating is a sprawling technological slum. A company with no zoning laws, no master plan, and a permanent traffic jam at every intersection of information. Trying to get a simple report that combines sales data and inventory data can take weeks of manual effort because the systems don't talk to each other. It's a city at war with itself. This is the chaos that gives birth to the enterprise architect. The enterprise architect is not the mayor making political speeches, and they're not the construction worker pouring the concrete. The enterprise architect is the chief city planner. Their job is to climb into a helicopter and look at the entire city, the entire enterprise from 10,000 feet. They hold the master blueprint. They don't dictate the color of the curtains in every building, but they define the fundamental rules for how the city grows. They are the ones who create the zoning map. They say, this area is for heavy-duty data processing. This area is for customer-facing applications, and all new constructions must connect to this standardized, citywide data pipeline. They establish the building codes that ensure quality and security. They design the transportation system, the networks and integrations that allow information to flow freely and quickly from the financial district to the industrial park. They ask the hard long-term questions that no one else is asking. Does building another new shiny application here really serve the city's long-term goals? Or will it just put an unsustainable strain on our infrastructure? Are we building a city that's resilient and ready for the future? Or are we just building a collection of short-term fixes that will become tomorrow's nightmare? The enterprise architect is the guardian of coherence, the guardian of the big picture. So what does this master blueprint actually look like? It isn't just one giant, overwhelming document. It's a set of interconnected maps, or what we call architectural domains. For the sake of clarity, we're going to focus on the 4 most common domains. Think of them as the 4 essential layered maps you'd need to understand and manage our growing city. The first and most important is the business architecture map. This isn't about technology at all. This is the why map. It answers the fundamental question, what does our city, our business actually do? It maps out the core capabilities of the company. We are capable of marketing products, processing payments, managing supply chains, and providing customer service. It defines the major value streams, showing how we deliver value to our customers, from the first click on an ad to the final delivery of a product. This map connects our day-to-day operations to our highest-level strategic goals. If the company strategy is to become the most customer-centric company in the world, the business architecture map shows us exactly which capabilities and processes we need to invest in to make that a reality. Without this map, you're just a city building roads and skyscrapers with no idea where people actually want to go or what they want to do. Second, we have the data architecture map. If business architecture is the why, data architecture is the what. It's the map of the city's most critical utility, information. Data is the water, the electricity, the lifeblood of the modern enterprise. This map shows where all the critical data resides. Where is our customer information stored? Is it in one clean central reservoir? Or is it scattered in 100 different contaminated wells across the city? It shows how data flows through the city's pipes. When a customer places an order, how does that information flow from the sales system to the warehouse system to the finance system? Is the flow clean, secure, and instantaneous? Or is it a leaky, manual bucket brigade process? A good data architecture ensures that decision makers have access to clean, reliable water whenever they turn on the tap, instead of having to guess what's true. Third is the application architecture map. This is the map of the buildings themselves. It's a catalog of every single software application in the company. The giant SAP skyscraper that runs finance, the sprawling Salesforce complex that houses the sales team, the thousands of smaller tools, spreadsheets, and custom-built sheds that every department has accumulated over the years. The application architect looks at this city skyline and brings sanity to it. They point out, wait a minute, we have 7 different buildings, all from different developers, that are supposed to do the exact same thing, manage contracts. This is costing us a fortune in licensing and maintenance. Their job is to rationalize this portfolio. They create a plan to decommission the old, crumbling buildings that are a security risk and consolidate the redundant ones into a single, efficient, modern structure. This map prevents the city from becoming a cluttered, expensive, and unmanageable mess of app sprawl. And finally, we have the technology architecture map. This is the map of the city's foundation. What is everything built on? It's the bedrock, the power grid, the road network, the sewer system. In corporate terms, this is the hardware, the servers, the cloud platforms, the networks, and the operating systems that everything else runs on. This layer is invisible to most people, but it is absolutely critical. The technology architecture ensures this foundation is solid, secure, and scalable. It asks, is our network road wide enough to handle the coming explosion of data traffic? Is our cloud power grid robust enough to support our future growth? Or is it going to buckle under pressure? A weak foundation puts the entire city, every building and every citizen at risk. So there you have it. The 4 layers: business, data, application, and technology. BDAT. Each is a different lens for viewing the same enterprise. But the true power of enterprise architecture is seeing how they are all linked together. A strategic goal from the business architecture, like we want to offer personalized recommendations to our customers, directly impacts the other layers. It requires a new way to collect and analyze customer information, which is data architecture. That, in turn, requires a new machine learning application, which is application architecture. And that new application needs to run on a high-performance computing platform, which is technology architecture. It's a direct line of sight, a golden thread, that connects a high-level strategic objective all the way down to a specific server in a data center. It transforms vague business wishes into a concrete, executable, and coherent plan. It is the fundamental difference between a city that grows by accident and a city that grows with purpose and design. But here's the critical question. A beautiful blueprint is worthless if the construction crews all ignore it and just build whatever they want. How do you actually get thousands of people, hundreds of teams, across a massive organization to all follow the same master plan? How do you enforce the zoning laws and the building codes? That requires more than just maps. It requires a system. It requires established methods and frameworks to turn the blueprint into a living, breathing reality. And it's those powerful frameworks that we're going to break down next. So, if the blueprint is the what, the frameworks are the how. They are the scaffolding for our thinking, the toolbox we use to make sense of the immense complexity we just talked about. A framework in enterprise architecture isn't a rigid, one-size-fits-all instruction manual. It's more like a professional chef's kitchen. It has designated stations, one for prep, one for cooking, one for plating. It has a standard set of tools, knives, pans, mixers. And it has a philosophy, a method for combining ingredients to create a world-class meal. You can cook anything in that kitchen, from French cuisine to Italian, but the structure, the process, the framework of the kitchen itself ensures quality, consistency, and efficiency, no matter what's on the menu. Without a framework, enterprise architecture is just chaos. It's a bunch of smart people in a room, all drawing their own maps, all using their own symbols, all arguing about which road is the most important. You end up with what we call architecture by PowerPoint. Beautiful slides and diagrams that look impressive in a meeting, but have zero connection to reality. They're disconnected, they don't influence decisions, and they become outdated the second the meeting is over. It's like having 100 different building codes for a single city block. Nothing gets built, and if it does, it's a chaotic mess that's bound to collapse. A framework solves this. It provides a common language, a shared set of tools, and a repeatable process. It ensures that when one architect talks about a business process, another architect knows exactly what they mean, what level of detail is required, and how that process connects to the company's technology and data. It turns the art of architecture into a disciplined engineering practice. It's the system that allows us to manage millions of moving parts without losing our minds. Over the years, several major schools of thought or frameworks have emerged. Think of them as different philosophies for city planning. You have the grand, comprehensive approach, the minimalist, agile approach, the government-mandated approach. The most famous ones you'll hear about are the Zachman framework, TOGAF, which stands for the Open Group Architecture Framework, FEAF for the U.S. federal government, and the Gartner methodology. Each has its own strengths, its own focus, and its own passionate followers. To really understand EA, we need to understand how these frameworks think. And the best place to start is with the granddaddy of them all, the one that laid the foundation for everything that followed, the Zachman framework. John Zachman, an early pioneer at IBM, had a revolutionary idea back in the 1980s. He wasn't trying to create a step-by-step process. He was trying to create a way of thinking, a way to classify and organize all the architectural stuff of a company. He looked at how other mature industries like construction and manufacturing handled complexity. They didn't just have one blueprint for a skyscraper. They had dozens. They had the architect's sketches, the engineer's structural diagrams, the plumber's piping plans, the electrician's wiring schematics. Each one was a valid and necessary description of the same building, just from a different perspective and for a different purpose. Zachman realized that an enterprise is no different. It's just infinitely more complex than a building. So he asked a simple, powerful set of questions. These are the same basic interrogative questions a journalist uses to understand a story. What, how, where, who, when, and why? Think about it. To describe anything completely, you need to answer these 6 questions. What are the things? The data. How does it work? The function or process. Where is it? The network or location. Who is involved? The people or roles. When do things happen? The time or events. And most importantly, why is this important? The motivation or goal. That's the first dimension of his framework. But then he added the second brilliant dimension, perspective. He recognized that the answers to those 6 questions change depending on who you are. The CEO has a very different perspective than a software developer. So, he defined a series of roles or viewpoints that map roughly to the building analogy. At the very top, you have the planner's view. This is the big picture, the scope. Think of it as the real estate developer deciding on the location and general size of the building. Then you have the owner's view. This is the business model. The future building owner who describes what kind of rooms they need, how they will be used. Below that is the designer's view, the system model. This is the architect who turns the owner's wishes into formal blueprints. Then the builder's view, the technology model. The general contractor who has to figure out what materials and technologies to use. Then the subcontractor's view, the detailed specifications. The plumber or electrician who needs the precise, detailed schematics for their specific part of the job. And finally, you have the actual functioning enterprise itself, the finished building. What Zachman did was put these 2 dimensions, the 6 questions and the different perspectives, into a grid, a matrix, a 6x6 grid with 36 cells. And this simple grid became a kind of periodic table for enterprise architecture. Each cell in that grid represents a specific, unique architectural artifact, a specific type of map or model. Let's make this real. Take the what column, the data. From the planner's perspective, the top row. What is just a list of the major things the business cares about. Customers, products, orders. That's it. Move down to the owner's perspective. What becomes a conceptual model? How do those things relate? A customer places an order. An order contains a product. We start to see the business rules. Move down to the designer's perspective. What is now a logical data model? This is where we define attributes. A customer has a name, an address, a phone number. An order has an order date, a total amount. It's getting more detailed, more structured. Move down to the builder's perspective. What becomes a physical data model? Now we're talking about database tables, columns, data types. How is this information actually going to be stored in a specific technology like Oracle or SQL Server? And finally, at the subcontractor level, it's the actual data definition language, the code that creates the tables in the database. Do you see the power of this? We just took one concept, what/data, and looked at it through 5 different lenses, moving from a high-level business idea all the way down to a line of code. And every single view is a correct and necessary description of the enterprise's data. Zachman's framework forces you to consider all of them. You can do the same thing for the how column, the processes, the where column, the network, and all the others. Each cell demands an answer. The genius of the Zachman framework is that it's a perfect tool for diagnostics. You can take all of your company's existing documentation, all the process maps, network diagrams, or charts, strategy documents, and you can try to place them into the 36 cells of the grid. Instantly, you'll see where the gaps are. You might find you have tons of documentation in the builder and subcontractor rows, lots of detailed technical diagrams, but the top 2 rows, the planner and owner views, are completely empty. This is an incredibly common problem. It means your IT department is busy building things without a clear understanding of the business strategy or the business model they're supposed to be supporting. The why is missing. The framework makes these gaps painfully, obviously visible. It's a checklist for completeness. It ensures you've thought about everything from every angle. But here's the crucial thing to understand about Zachman. It's a taxonomy. It's a classification scheme. It gives you the empty filing cabinet with 36 perfectly labeled drawers. Tells you what artifacts you should probably have. What it doesn't do is tell you how to create them. It doesn't tell you which cell to fill out first. It doesn't give you a step-by-step process for getting from the CEO's vision to a working system. It's a static map of the territory, not a GPS navigator giving you turn-by-turn directions. It describes the destination but not the journey. And that's not a criticism. It was never intended to be a process. But in the real world, architects need a process. They need a method. They need to know what to do on Monday morning. They need a way to move from the current messy state of their city to the future well-planned state. They need a repeatable step-by-step approach to actually do the work of architecture. And to get that, we have to turn to a different and by far the most widely used framework in the world. A framework that is all about the process, the method, the journey of transformation. This framework is called TOGAF, which stands for the Open Group Architecture Framework. And if Zachman is the blueprint, TOGAF is the step-by-step construction manual. It's not a theory, it's a method. A detailed phase-by-phase playbook for taking a company from where it is today to where it needs to be tomorrow. It's used by thousands of organizations, from governments to Fortune 500 giants, because it provides a common language and a repeatable process for the messy, chaotic work of enterprise-level change. At the absolute heart of TOGAF is a concept called the Architecture Development Method, or the ADM. This is the engine. This is the recipe. And it's best visualized as a cycle, a continuous loop of activity. Think of it like a wheel that a business can turn again and again to constantly evolve and improve. This wheel has a series of distinct phases, each with a clear purpose, that guide an architect from a vague idea all the way to a successfully implemented reality. So let's walk around that wheel. Let's follow the journey of a major transformation, phase by phase, using the ADM as our guide. It all starts with what's called the preliminary phase. This is really phase 0. Before you can even think about changing the business, you have to get your own house in order. This phase is all about setting up the architecture team for success. It answers questions like, who are our architects? What tools will we use? What are our guiding principles? What parts of the business are we even going to focus on? It's like a chef preparing their kitchen before a big dinner service. Sharpening the knives, organizing the ingredients, checking the ovens. You don't just start cooking. You prepare. This phase establishes the how before you get to the what. Once the kitchen is set, the real cooking begins with phase architecture vision. This is the most critical phase of all because it sets the North Star for the entire journey. It starts with a request from the top, a CEO who says, we need to increase our market share by 20%. Or, we need to become the most customer-centric company in our industry. The architect's job in Phase A is to take that high-level business dream and translate it into a clear, compelling vision for change. What does that dream actually mean for our business processes, our data, our technology? This phase is about defining the problem, identifying the stakeholders, getting buy-in, and painting a picture of the desired future that everyone can understand and rally behind. If you get Phase A wrong, everything that follows will be a waste of time. With a vision set, we move into the core design work, which happens across 3 phases, B, C, and D. This is where we create the detailed blueprints for the future. Phase B is for business architecture. Here, we forget about technology for a moment. We focus entirely on the business itself. We map out the current business processes, the as-is. Then we design the future processes, the to-be, that will be needed to achieve the vision from Phase A. We ask, what new capabilities does the business need? How do our value streams need to change? Who does what? This is about redesigning the operational DNA of the company. Next, in Phase C, we tackle the information systems architecture. This phase is so important it's broken into 2 parts, data and applications. First, the application architecture. Based on the new business processes from Phase B, what software do we need to support them? Do we need a new CRM system? A new logistics platform? Do we need to retire a dozen legacy applications that are holding us back? We define the portfolio of applications that will run the future business. Then comes the data architecture. What information do these applications need to share? Where does customer data live? How does an order flow through our systems? This phase designs the logical and physical data models, ensuring that information is treated as a strategic asset, consistent, secure, and available where it's needed. Following that, we arrive at Phase D, technology architecture. This is the foundational layer. What hardware, networks, and infrastructure are required to run all the applications and manage all the data we just defined in Phase C? Are we moving to the cloud? What kind of servers do we need? What does our network infrastructure look like? This is the plumbing, the electricity, the foundation of the house. It's the essential underlying technology stack that makes everything else possible. At the end of Phase D, we have two complete pictures: a detailed blueprint of where we are today, the as-is architecture, and a detailed blueprint of where we need to go, the to-be architecture. Now, the obvious question is, how do we get from here to there? That's what the next two phases are all about. Phase E is opportunities and solutions. It's one thing to have a beautiful blueprint for a future state. It's another thing to actually build it. We can't just shut down the company for 2 years and rebuild everything from scratch. The change has to happen in manageable, logical steps. In this phase, architects identify the gaps between the as-is and the to-be, and group them into concrete projects or work packages. They look for logical stepping stones, quick wins, and foundational projects that need to happen first. This is where the grand vision is broken down into an actionable portfolio of potential projects. This leads directly into Phase F, migration planning. Here we take that portfolio of projects from Phase E and put them on a timeline. We create the roadmap. This phase is about sequencing and prioritization. What are the dependencies? Which project has to finish before another can start? What are the costs and benefits of each one? The output of Phase F is a detailed implementation and migration plan that says, in Q1, we will do these 3 projects. In Q2, we'll do these 4. It turns the architectural dream into a budgeted, scheduled reality that the business can execute. Now the plan is set. The roadmap is clear. It's time to build. Phase G is implementation governance. This is a crucial distinction. Enterprise architects are typically not the ones writing the code or installing the servers. That's the job of the solution architects and development teams. The role of the enterprise architect in Phase G is one of governance, of oversight. They are the guardians of the original vision. As the project teams are building, the architect constantly checks in. Are they following the blueprint? Are they using the right technologies? Does the solution being built actually meet the business requirements it was supposed to? The architect provides guidance, resolves issues, and ensures the final implementation is compliant with the architecture. Finally, after all that work, we arrive at the new state. But the work is never truly done. Business doesn't stand still. That brings us to Phase H, architecture change management. The moment your new system goes live, the world has already started to change. A new competitor emerges, a new technology is invented, a new regulation is passed. This phase establishes the process for managing changes to the architecture over time. It ensures that as new needs arise, they are handled in a disciplined way, rather than through chaotic, one-off fixes that slowly erode the integrity of the design. This phase is what makes the ADM a cycle, not a straight line. The output of change management often becomes the input for a new spin around the wheel, starting a new Phase A with a new vision. And throughout this entire cycle, right in the center of the wheel, is a constant process called requirements management. At every single phase, architects are gathering, analyzing, and validating requirements to ensure the work is always anchored to real, tangible business needs. This architecture development method is the core of TOGAF. It provides a structured, repeatable, and logical journey. It connects the highest-level strategic goals of a CEO directly to the specific technology being installed in a data center. It's the discipline that turns the art of architecture into an engineering practice, ensuring that massive, complex transformations are not a gamble, but a well-managed process. But knowing the process is only half the battle. As architects move through these phases, what are they actually creating? What are the documents, the diagrams, the models they produce? What are the tangible artifacts that make the architecture real? The tangible artifacts that make an architecture real are its blueprints. But not just one blueprint like you'd have for a house. An enterprise is infinitely more complex than a single building. So enterprise architects create a whole library of interconnected blueprints, models, and catalogs that, together, describe the organization in its entirety, past, present, and future. These aren't just dusty documents sitting on a shelf. They are living tools used every single day to make better decisions. Think of them as the collective intelligence of the organization made visible. So let's pull back the curtain and look at the most critical artifacts an enterprise architecture practice produces. First, and perhaps most foundational, are the architecture principles. If the architecture is the city plan, The principles are the city's constitution. They are a short, concise set of fundamental rules and beliefs that guide all technology and business decisions. A principle isn't a vague statement like, "We will be innovative." It's a specific, actionable guide. For example, a common principle is cloud first. This means for any new project, the default option must be a cloud-based solution. You have to actively justify not using the cloud. Another might be buy before build, meaning the company will always look for an off-the-shelf software solution before committing resources to building a custom one. These principles act as a tiebreaker in debates and ensure that thousands of individual decisions, made by different teams, all align with the same strategic direction. They are the North Star for everyone. Next, we have one of the most powerful and misunderstood artifacts, the business capability map. This is not an org chart. An org chart shows who reports to whom. A capability map shows what the business does, completely independent of the people or departments who do it. A capability is the ability to do something to achieve a business outcome. For example, a retail company has capabilities like inventory management, customer relationship management, and online order fulfillment. These capabilities exist whether the company has 1 employee or 10,000. They exist whether the work is done by a human, a piece of software, or a robot. Why is this so important? Because it decouples the stable, slow-moving essence of the business, its capabilities, from the fast-changing parts, like its organizational structure, or the specific applications it uses. People change teams, departments get reorganized, software gets replaced. But the fundamental need to manage inventory remains. By mapping these capabilities, architects can see the entire business on a single page. They can then overlay information onto this map. Which capabilities are performing poorly? Which ones cost the most money? Which capabilities are supported by old, outdated technology? Suddenly, you have a heat map of your entire organization, showing you exactly where the problems and opportunities are. It's like having an MRI of the business itself, allowing you to pinpoint issues with surgical precision. Flowing from capabilities, we have value streams. If a capability map is a static map of what you can do, a value stream is a dynamic map of how you deliver value to a customer. It shows the end-to-end sequence of activities required to provide a product or service. Let's take a simple example, ordering a pizza. The value stream starts the moment a customer thinks, "I'm hungry." It includes the activities of browse menu, place order, process payment, prepare pizza, bake pizza, package for delivery, and deliver to customer. By mapping this flow, architects can identify bottlenecks, delays, and inefficiencies. They can ask, where does the process slow down? Where do we create the most value for the customer? Where do we have waste? This view is crucial for connecting IT investments directly to customer outcomes. Improving a system that supports a critical stage in a key value stream has a much bigger impact than optimizing a system that supports a minor, internal process. Now let's get into the technology itself. A core artifact here is the Application Portfolio Catalog. This is essentially a detailed inventory of every single application the company uses. But it's so much more than a list. For each application, it captures vital information. What business capabilities does it support? Who owns it? What technology is it built on? How much does it cost to run? And most importantly, what is its business value and technical condition? Architects often use a model called TIME, which stands for Tolerate, Invest, Migrate, and Eliminate. They categorize every application. Invest in the strategic, modern apps. Tolerate the ones that work but aren't perfect. Migrate the ones that are functional but on old technology. And eliminate the redundant, low-value, or broken ones. This process is like a corporate version of spring cleaning for your software. It allows the organization to systematically reduce complexity, cut costs, and focus resources on the applications that truly matter. Without this catalog, a company is flying blind, often paying for a dozen different applications that all do the same thing. To prevent that portfolio from getting messy again, architects create a Technology Reference Model, or TRM. Think of this as the company's official list of approved building materials. If you're building a house, you can't just have contractors showing up with any random type of wood or pipe they found. That would lead to chaos. The architect specifies approved materials to ensure quality, consistency, and compatibility. TRM does the same for technology. It says, for a database, you can use Oracle or SQL Server. For a programming language, we support Java and Python. For cloud services, we use Amazon Web Services. This doesn't mean developers have no choice, but it limits the choices to a curated, supported, and secure set of standards. This massively simplifies integration, reduces security risks, and lowers support costs. It stops the company from becoming a chaotic museum of 1,000 different technologies that don't talk to each other. Of course, we have to talk about the diagrams, the actual pictures. These are the blueprints most people imagine when they hear the word architecture. And they are critically important for communication. Architects create many types of diagrams. There are high-level context diagrams that show how a system fits into the broader enterprise, perfect for explaining a project to a CEO. There are detailed solution architecture diagrams that show servers, databases, and network connections, designed for the engineering team that will actually build it. There are data flow diagrams that trace how information moves through a process, essential for ensuring privacy and security. The key skill of an architect is creating the right view for the right audience. They translate immense complexity into a visual story that different people can understand, debate, and use to make informed decisions. Finally, all of this comes together in a series of roadmaps. A roadmap is the link between strategy and execution. It's the GPS that shows how to get from the current state architecture to the desired future state. It's a timeline that lays out the sequence of projects and initiatives needed to make the future a reality. For example, a roadmap might show that in Q1, we will decommission 3 old applications. In Q2, we will begin migrating our customer data to a new cloud platform. In Q3, we will launch the new mobile app that uses that platform. The roadmap shows how all the pieces fit together over time. It ensures that the work being done today is a deliberate step towards the vision of tomorrow, not just a random series of disconnected projects. These artifacts, principles, capability maps, value streams, portfolios, reference models, diagrams, and roadmaps form a living, breathing model of the enterprise. They are not one-time efforts. They are constantly updated and refined as the business changes. They provide a shared language and a common understanding that aligns business leaders and technology teams. They transform decision-making from an art, based on gut feelings, into a science based on evidence and a clear vision for the future. But creating these powerful artifacts requires a unique set of skills and a specific group of people. This isn't the work of one lone genius locked in a room. Who are these architects? What are their different roles? And how do they work together to build and maintain this digital model of the entire organization? Let's think of it less like a single architect and more like a team of city planners and specialized engineers. Each has a unique perspective, a different zoom level, but they are all looking at the same city, the same enterprise. Their shared goal is to make the city functional, resilient, and ready for future growth. At the highest level, you have the enterprise architect. This is the master city planner. The enterprise architect, or EA, isn't concerned with the color of the bricks on a single building or the type of plumbing in one apartment complex. They are concerned with the entire system. They ask the big sweeping questions. Where should we put the new industrial zone, the new business division, so it has access to the main data highways? What are our citywide zoning laws, our technology standards, that every new construction project must follow? How do we ensure our power grid, our IT infrastructure, can support the city's population growth over the next 10 years? The enterprise architect's primary role is strategic alignment. They are the crucial link between the company's C-suite, the mayor's office, and the actual execution on the ground. When the CEO says, "Our 5-year plan is to become the most customer-centric company in our industry," the EA translates that business vision into a technology roadmap. They'll say, "Okay, to achieve that, we need to consolidate our 3 different customer databases into a single source of truth. We need to invest in a cloud-based analytics platform to understand customer behavior, and we need to retire these 10 legacy applications that are creating a terrible customer experience." They create the master plan, the guiding principles, and the high-level blueprints that all other architects will use as their North Star. They see the forest, not just the trees. Now, if the enterprise architect is the city planner, who designs the specific skyscraper, the new sports stadium, or the suspension bridge? That's the solution architect. This role is project-focused. A business unit comes forward with a specific problem or opportunity, like, we need to build a new mobile app for our customers, or we need to overhaul our supply chain management system. The solution architect is the one who designs the end-to-end solution for that specific problem. They take the master plan from the enterprise architect, the zoning laws, the required materials, the connection points to city infrastructure, and they design a structure that not only works beautifully on its own, but also fits perfectly into the surrounding city. They are masters of trade-offs. They have to consider everything. Will this be built on-premise or in the cloud? What programming languages and frameworks should we use? How will it connect to our existing payment systems? How will it handle security? How much will it cost to build and maintain? The solution architect creates the detailed technical blueprint for a single project, ensuring it's feasible, secure, resilient, and most importantly, aligned with the enterprise-wide strategy set by the EA. They are the bridge between the grand vision and the tangible reality of a single complex project. They see the most important group of trees in the forest and design how they'll grow together. But a city planner and a building designer can't know everything. They need specialists. They need experts who understand the electrical grid, the water systems, the traffic patterns, and the economic policies in incredible detail. This is where domain architects come in. These are the deep subject matter experts who focus on one specific area, or domain, across the entire enterprise. Let's start with the business architect. This role is often misunderstood, but it's critically important. The business architect is concerned purely with the business itself, completely separate from technology. They are the urban sociologists and economists of our city. They map out the city's real-world activities. They don't ask what software we use for invoicing, they ask what is the process of invoicing? What are the steps, who is involved, what information is needed? They map the company's capabilities. For example, a capability might be process customer payments or manage inventory. They then analyze these capabilities for efficiency and effectiveness. They are the ones who can identify that two different departments are using completely different redundant processes to do the exact same thing. By creating a clear blueprint of how the business operates, they provide the essential context for all technology decisions. They define the why and the what before anyone else starts talking about the how. Next, you have the data architect. In our city analogy, data is the water. It flows everywhere, it's essential for life, it needs to be clean, it needs to be accessible, and it needs to be secure. The data architect is the master of the city's water supply. They design the reservoirs, the databases, and data warehouses. They map the pipelines, the data flows and integrations between systems. They set up the purification plants, the data quality and governance rules. And they manage the security, ensuring that sensitive information doesn't leak into the public water supply. They answer critical questions like, what is our single source of truth for customer information? How do we define a sale consistently across the entire company? How do we comply with data privacy regulations like GDPR or CCPA? Without a strong data architect, the enterprise drowns in a sea of inconsistent, unreliable, and insecure information. Then comes the application architect. If data is the water, applications are the buildings themselves. The application architect is the expert on the entire portfolio of buildings in the city. They maintain the master registry of every piece of software the company uses, from massive ERP systems to small specialized tools. Their job is to ensure these buildings are structurally sound, well-maintained, and work together effectively. They focus on rationalizing the application portfolio, deciding which old, crumbling buildings need to be demolished, application retirement, which ones can be renovated, upgraded, and where new buildings need to be constructed, new software development. They also define the standards for how applications should communicate with each other, creating the building codes for APIs and integration patterns, ensuring that a new skyscraper can easily connect to the city's power and data lines without causing a citywide blackout. Finally, we have the technology architect, sometimes called the infrastructure architect. This is the bedrock. This is the ground the city is built on. The technology architect is the master of the physical and digital infrastructure. The roads, the bridges, the power plants, the communication towers. In the tech world, this means the servers, the networks, the cloud platforms like AWS or Azure, the operating systems, and the data centers. They focus on the non-functional requirements, the ILITs, like reliability, scalability, and performance. They answer the questions. Can our network handle the traffic if our new mobile app goes viral? Is our cloud configuration cost-effective and secure? How do we recover quickly if a data center goes down? They build and maintain the powerful, resilient foundation upon which everything else, applications, data, and business processes, depends. So you have this fellowship of architects, the enterprise architect setting the overall city plan, the solution architect designing a specific, complex project like a new stadium, and the domain architects providing deep expertise, the business architect defining the economic activity, the data architect managing the water supply, the application architect overseeing the buildings, and the technology architect ensuring the foundation is solid. They don't operate in a strict hierarchy. It's a collaborative, often messy, and constant conversation. The solution architect's design for a new building might challenge the city's existing zoning laws, forcing the enterprise architect to reconsider the master plan. A new data privacy law might force the data architect to mandate changes that affect every application and infrastructure architect in the company. It's a dynamic system of checks and balances, all working to ensure the enterprise, our digital city, doesn't just function for today, but is ready to grow, adapt, and thrive in the future. But having this team of brilliant architects isn't enough. A plan on a piece of paper is just a drawing. How do they codify these plans? What are the actual documents, diagrams, and models they create to communicate this grand vision? What do these architectural blueprints actually look like? This collection of documents, diagrams, and models is what we call architectural artifacts. Think of it as the enterprise architect's library of blueprints. But unlike a simple house blueprint, these plans exist at different levels of zoom, from a satellite view of the entire continent down to the electrical wiring of a single room. Let's start at the highest, most abstract level. Before you can draw a single building, you need to understand the purpose of the city itself. What does this city do? Is it a center for commerce? A hub for manufacturing? A residential paradise? This is the fundamental question of business capability mapping. A business capability map is not a process diagram. It doesn't show how you do something. It shows what you are capable of doing independent of who or what system is doing it. For example, a retail company has capabilities like manage inventory, process payments, market products, and fulfill orders. These are the fundamental, unchanging pillars of the business. They existed when the company was a single brick-and-mortar store, and they will exist when it's a global e-commerce giant powered by AI. This map is the enterprise architect's true north. It's a single page, a single view, that shows the entire business as a collection of stable, understandable blocks. Why is this so powerful? Because it allows architects to have conversations with executives in their own language. They can point to the manage inventory capability and ask, how well are we doing this today? Are we using 5 different disconnected systems to achieve one core capability? Is this area a source of competitive advantage or a source of pain? They can color code the map, red for capabilities that are failing, green for those that are excelling. Instantly, the entire organization can see where the problems are and where investment is needed, completely detached from the messy details of the underlying technology. It is the ultimate strategic alignment tool. It's the zoning map for the entire enterprise city. Okay, so we have our zones. We know we need a financial district, a residential area, an industrial park. Now, what buildings currently exist in those zones? This brings us to the next critical artifact, the application portfolio catalog. This is exactly what it sounds like, a complete inventory of every single piece of software the company uses, from the massive ERP system that acts as City Hall, to the tiny, forgotten departmental spreadsheet that's quietly holding up a critical process like a single rusty screw. For each application, the architect documents everything. What business capability does it support? What department owns it? What technology is it built on? How much does it cost to maintain? Is it a modern, well-supported skyscraper or a crumbling, asbestos-filled tenement building slated for demolition? By mapping these applications back to the business capability map, the architect reveals the hidden reality of the organization. They might discover that the process payments capability is supported by 7 different redundant applications, costing millions a year. They might find that a critical capability like analyze customer behavior has no dedicated application at all and is being done manually. This catalog isn't just a list. It's an X-ray of the enterprise's technological health. It's the city planner's detailed survey of every structure, revealing which ones are assets and which are liabilities. Now we have the zones and the buildings, but what are we allowed to build with? You can't just build a skyscraper out of popsicle sticks and glue. You need standards. This is where the Technology Reference Model, or TRM, comes in. The TRM is the approved catalog of building materials for the entire enterprise. It specifies the official programming languages, the approved database systems, the standard cloud providers, the required security protocols. It's the enterprise's building code. The purpose isn't to stifle creativity, it's to prevent chaos. By having a standard set of technologies, the company ensures that its different systems can actually talk to each other. It reduces complexity, making it easier to train people and maintain systems. It improves purchasing power with vendors. It ensures a baseline of quality and security. If a project team wants to use a new non-standard technology, a fancy new type of composite material, they have to go through an architectural review process. They need to justify why the standard materials won't work and prove that their new choice is safe, scalable, and sustainable. The TRM creates freedom within a framework, ensuring that while individual buildings might look different, they are all built to last and can connect to the city's power grid and water supply. Speaking of the power grid, how do all these buildings connect? A city with beautiful, isolated skyscrapers is useless. They need roads, power lines, water pipes, and communication networks. In the enterprise, this is the world of integration patterns and data flow diagrams. These artifacts are the utility maps of the organization. They show how data flows from the customer relationship management system to the order fulfillment system. They define the standard ways applications should communicate. Are they sending messages through a central bus station, like an enterprise service bus, or are they making direct point-to-point calls to each other? An architect will create diagrams that show the major information arteries of the company. Where does customer data originate? Where is it stored? Which systems are allowed to modify it? This is critically important. Without these maps, you get data chaos. You have different departments with different versions of the truth. You have fragile, undocumented connections that break in the middle of the night, bringing the entire supply chain to a halt. These diagrams make the invisible visible, showing the digital plumbing that keeps the entire city running. So we have the capabilities, the applications, the technology standards, and the integration patterns. These are the blueprints for the city as it exists today. But the whole point of enterprise architecture is to manage change and guide the city into the future. That's where the most important artifact of all comes in: the roadmap. A roadmap is a plan that shows how the enterprise will evolve over time. It takes the as-is state, the current city, and plots a course to a to-be state, the gleaming city of the future. But it's not a single giant plan. It's a series of interconnected roadmaps. There's a business roadmap, showing how capabilities will evolve. For example, in Q1 we will focus on improving inventory management. And in Q3 we will introduce a new capability for personalized customer recommendations. Underpinning that is an application roadmap. It shows which applications will be retired, which will be upgraded, and which new ones will be introduced to support the business roadmap. For example, to enable personalized recommendations, we will deploy a new AI engine in Q2 and retire 3 legacy marketing systems by the end of the year. And supporting that is a technology roadmap. It might show the plan to migrate from on-premise data centers to the cloud over the next 3 years, or the phased rollout of a new security platform. These roadmaps are the master plan in motion. They are the architect's tool for communicating the sequence of change to the entire organization. They ensure that everyone is building in the same direction at the right time. They prevent a situation where one team builds a new highway exit, but the corresponding city street won't be built for another 5 years. They synchronize the immense, complex, and distributed efforts of the entire enterprise into a single coherent symphony of progress. From the 30,000-foot view of a capability map to the granular, time-based plan of a technology roadmap, these artifacts are how enterprise architects turn abstract strategy into concrete, executable reality. They are the shared language, the single source of truth that allows thousands of people to build one single, unified, and powerful enterprise. But creating these diagrams is one thing. Keeping them alive, accurate, and relevant is another challenge entirely. An out-of-date blueprint is worse than no blueprint at all. So how do architects manage this incredible library of knowledge? How do they ensure it reflects reality and effectively governs decision-making? What is the system, the methodology that brings all of this together into a living, breathing practice? The answer lies in structure, in discipline, in a shared understanding of how to see the whole elephant. Enterprise architects don't just invent their methods from scratch for every new problem. They stand on the shoulders of giants, using established, battle-tested approaches called enterprise architecture frameworks. Think of it like this. You wouldn't build a skyscraper without blueprints, building codes, and a detailed project plan. You wouldn't design a new car without established principles of aerodynamics, mechanical engineering, and safety standards. These frameworks, these codes and principles provide the scaffolding for creation. They ensure that what you're building is coherent, safe, and fit for purpose. An enterprise architecture framework does the exact same thing for a business. It's a toolbox, a library of best practices, and a common language all rolled into one. It provides a structured method for organizing, planning, designing, and governing the enterprise's architecture. It gives architects a repeatable process, a way to classify the mountains of information they gather, and a way to communicate their vision to everyone from the CEO to the software developer. Without a framework, EA is just a collection of well-intentioned but disconnected diagrams and opinions. With a framework, it becomes a professional discipline. Now, there isn't just one single framework to rule them all. Different frameworks have emerged over the years, each with its own strengths and focus. But to truly understand the landscape, we need to talk about the two titans that have fundamentally shaped the practice: the Zachman framework and the Open Group Architecture framework, better known as TOGAF. Let's start with the grandfather of them all, the Zachman framework. Created by John Zachman while he was at IBM in the 1980s, it's less of a how-to guide and more of a what's-what guide. Zachman's genius was to look at how other mature disciplines, like civil engineering and manufacturing, organized complex information. He realized they all had a common way of thinking, and he applied it to the enterprise. The result is a simple but incredibly powerful two-dimensional grid, a matrix. Think of it as the periodic table for enterprise artifacts. The columns of this grid ask the fundamental questions of communication. What? How? Where? Who? When? And why? These represent the different types of things you need to describe. What data do we have? How do our processes work? Where are our locations? Who are the people involved? When do events happen? And most importantly, why are we doing this? What's our motivation? The rows of the grid represent different perspectives or levels of detail, from the high-level, abstract view of a planner or CEO down to the concrete, detailed view of a technician or builder. You have the planner's view, the owner's view, the designer's view, the builder's view, and the subcontractor's view, ultimately leading to the functioning enterprise itself. The intersection of each column and row creates a cell that represents a specific type of architectural artifact. For example, the cell where the what column data meets the owner's row business view would contain the company's conceptual data model, the key things the business cares about. The cell where the how column process meets the designer's row system view would contain a logical process model, showing how a system accomplishes a task. The power of Zachman is its ability to enforce completeness. It's a classification scheme and ontology. It gives you a place for everything and helps you see if anything is missing. If you have a blank cell in your grid, you have a blind spot in your understanding of the enterprise. It forces a holistic, disciplined approach to documentation and thinking. However, what Zachman doesn't do is tell you how to create these artifacts or in what order. It gives you the filing cabinet, perfectly labeled, but it doesn't tell you the process for creating the files to put inside it. And that's where our second titan comes in, TOGAF. If Zachman is the what, TOGAF is the how. It is, by a huge margin, the most widely used enterprise architecture framework in the world today. Maintained by the Open Group, a global consortium, TOGAF is a comprehensive methodology. It provides a detailed step-by-step process for actually doing enterprise architecture. The heart of TOGAF is something called the Architecture Development Method, or the ADM. The ADM is a cycle, an iterative process that guides architects through the creation and management of an enterprise architecture. It's a roadmap for getting from A to B. It starts with a preliminary phase, which is all about getting ready, defining the principles, setting up the tools, and getting buy-in to even start the work. Then you enter the cycle proper with phase A, architecture vision. This is where you define the scope of the problem, identify the stakeholders, and create a high-level vision of the solution. It's about answering the question, what are we trying to achieve here? From there, the ADM dives into the core architecture domains. Phase B is business architecture, where you document the as-is and define the to-be business strategy, processes, and organization. Phase C is information systems architecture, which itself is split into data and application architectures. And Phase D is technology architecture, defining the underlying hardware, networks, and platforms. In each of these phases, you're analyzing the current state, defining the target state, and identifying the gaps between them. Once you know where you are and where you want to go, you move to Phase E, opportunities and solutions. This is where the architecture starts to become real. You group the work into logical projects and create a high-level implementation plan. Phase F, migration planning, takes that plan and turns it into a detailed roadmap. It sequences the projects, considers the costs and benefits, and creates a timeline for a successful transition from the as-is to the to-be. Phase G is implementation governance. This is critical. The architect doesn't just hand over the blueprints and walk away. They stay involved, providing oversight to the implementation projects to ensure that what gets built is actually compliant with the architecture that was so carefully designed. And finally, Phase H, architecture change management. The world doesn't stand still. New technologies emerge, business priorities shift, and the architecture must evolve. This phase establishes procedures for managing changes to the architecture in a controlled, coherent way, which then feeds back into a new cycle of the ADM. Running through the center of this entire cycle is requirements management, a constant process of capturing, validating, and prioritizing requirements to ensure the architecture is always focused on delivering real business value. So you can see the difference. Zachman provides a logical structure for information, the map. TOGAF provides a process for developing the architecture, the turn-by-turn directions. They aren't competitors, they're complementary. Many organizations use the TOGAF ADM as their process and use a Zachman-like grid as their content framework for organizing the artifacts they create along the way. Of course, these aren't the only two frameworks. There are others tailored to specific industries, like FEAF for the US federal government or DODAF for the Department of Defense. But Zachman and TOGAF represent the two fundamental schools of thought: the descriptive, classification-based approach versus the prescriptive, process-based approach. These frameworks are the machinery of the EA practice. They are the systems that allow architects to manage that incredible library of knowledge we talked about. They provide the rules, the checklists, and the roadmaps that ensure the practice is rigorous, repeatable, and aligned with the goals of the organization. They are what elevate enterprise architecture from an art to a true engineering discipline. But a framework is just a tool. A map is useless without a cartographer, and a process is useless without someone to execute it. So who is this person, the enterprise architect, and what does it actually take to wield these powerful tools effectively? What are the skills, the mindset, and the daily realities of the person at the center of this entire discipline? Let's start with a common misconception. The enterprise architect is not the most senior, all-knowing technical guru in the company. They are not the final boss of coding you have to defeat to get your project approved. While deep technical knowledge is part of the toolkit, it's far from the most important asset. The most effective enterprise architects are actually masters of a different domain, the domain of context. They are translators, diplomats, and storytellers who just happen to use technology as their primary medium. Think of the skills required in two broad categories: the foundational skills and the superpower skills. The foundational skills are the price of admission. You need a broad, T-shaped understanding of technology. This means you don't need to be the world's best expert in Kubernetes, but you absolutely need to understand what it is, why a company would use it, how it fits into a cloud-native strategy, and what its alternatives are. You need this level of understanding across a vast landscape: data architecture, network infrastructure, application development, cybersecurity, cloud computing, and emerging technologies like AI and machine learning. You are a generalist in the best sense of the word, able to see how all these specialized pieces connect to form a whole. Alongside this technical breadth, you need sharp business acumen. This is non-negotiable. An architect who talks only about technology without connecting it to business outcomes is an architect who will be ignored. You have to understand how the company makes money. What are its strategic goals for the next 5 years? Who are the competitors? What are the key market trends? You need to be able to read a balance sheet and understand the difference between CapEx and OpEx, because every architectural decision has financial implications. Recommending a move to the cloud isn't a tech decision. It's a financial decision that shifts spending from capital expenses to operational expenses, and you better be able to articulate why that's a good thing for the business. But those are just the foundations. The real leverage, the skills that separate a good architect from a legendary one, are the superpowers. And the first and most critical superpower is communication. An enterprise architect lives and dies by their ability to communicate a complex idea simply and persuasively to different audiences. In the morning, you might be in a boardroom explaining to the CEO how a new data platform will enable a 10% increase in market share. You'll use metaphors, business-centric language, and focus entirely on the outcome. An hour later, you might be in a meeting with lead engineers, diving into the technical trade-offs between two different database technologies, using precise technical language. You are a code switcher, a linguistic chameleon, translating between the language of business value and the language of technical implementation. You bridge the gap. The second superpower is influence without authority. Very rarely does an enterprise architect have a large team reporting directly to them. They cannot simply command people to follow their strategy. Instead, they must persuade, negotiate, and build consensus. They have to convince the project manager that adopting a standard technology, even if it adds a little time up front, will save the company millions in the long run. They have to show the development team that the architectural principles aren't bureaucratic hurdles, but guardrails designed to help them build better, more resilient systems faster. This is political skill. It's about understanding motivations, building relationships, and finding the win-win scenario. It's about being the person people seek out for advice, not the person they try to avoid. The third superpower is storytelling. Facts and figures are memorable, but stories are what truly change minds. A great architect doesn't just present a roadmap. They tell the story of the company's future. They paint a vivid picture of what the future state will look like, feel like, and what it will enable. They articulate the why behind the change in a way that resonates emotionally. Imagine a world where our customer service agents have every piece of customer information on a single screen, allowing them to solve problems in seconds, not minutes. That's the future we're building. That's infinitely more powerful than saying, we will integrate the CRM and the order management system. So that's the skill set. But what about the mindset? What goes on inside the head of a truly effective architect? First and foremost, they are long-term thinkers in a world that is obsessed with short-term results. They are constantly playing chess while everyone else is playing checkers. They have to champion the difficult long-term investments over the easy short-term fixes. They are the voice in the room asking, what are the consequences of this decision in 3 years? In 5 years? This often makes them seem like they are slowing things down, but in reality, they are preventing the future chaos that comes from an accumulation of short-sighted decisions. This long-term view is fueled by a holistic systems-thinking mindset. They don't see a marketing project or a finance system. They see a single interconnected enterprise. They understand that a change in the customer data model for a marketing campaign will have ripple effects on the finance department's reporting, the supply chain's logistics, and the support team's ticketing system. They connect the dots that no one else sees, identifying dependencies, risks, and opportunities that exist in the white space between organizational silos. Crucially, this visionary mindset must be tempered with extreme pragmatism. The stereotype of the ivory tower architect, who designs a perfect utopian architecture that is impossible to implement, is a real danger. A great architect knows that the perfect is the enemy of the good. They understand the real-world constraints of budgets, timelines, and existing skill sets. Their job is not to design the best possible architecture in a vacuum. It's to find the best possible path from the messy reality of today to a significantly better tomorrow, one practical, achievable step at a time. So what does this all look like on a Tuesday morning? What is the daily reality? Forget the image of a lone genius drawing diagrams in a quiet office. The reality is that an enterprise architect's calendar is usually a solid wall of meetings. They are professional collaborators. A day might involve a workshop with business stakeholders to define a new business capability, a one-on-one with the solution architect to review a project's design, a presentation to a governance board to get a new standard approved, and a call with the vendor to understand their product roadmap. They are constantly switching contexts, from high-level strategy to detailed technical discussions. They spend an enormous amount of time listening and asking questions. Their primary job is to seek understanding, to synthesize vast amounts of information from across the organization, and to reflect it back in the form of a coherent, actionable strategy. The diagrams, the roadmaps, the principles, these are not the work itself. They are the artifacts of the work. They are the tools used to facilitate conversation, drive alignment, and guide decision-making. The real work is the conversations, the negotiations, and the consensus building that leads to those artifacts. The role is a delicate balancing act. You have to be a governor, enforcing standards and ensuring alignment to prevent chaos. But you also have to be an enabler, providing patterns, tools, and platforms that help teams move faster and innovate. Say no too often, and you become the dreaded ivory tower. Say yes to everything and you're not doing your job. The art is in being the yes and, or the yes if, person. Yes, your team can use that new technology if you can demonstrate how it aligns with our cloud-first principle and integrates with our standard identity platform. Ultimately, the person who is the enterprise architect is a unique hybrid. They are a strategist, a technologist, a diplomat, a financier, and a teacher all rolled into one. They operate at the critical intersection of business and technology, shaping the capabilities that will determine whether the company thrives or fails in the digital age. They don't just design systems, they design the future of the business itself. But how is this critical role changing? In a world of agile development, DevOps, and decentralized decision-making, does the classic idea of a central architect even make sense anymore? The answer, in many organizations, is a resounding no. The classic ivory tower architect, handing down immutable laws from on high, is a relic of a slower, more predictable era. In a world that prizes speed, autonomy, and rapid iteration, a central architecture review board that meets once a month and acts as a bottleneck is not a strategic asset. It's an organizational liability. This is the friction that has given enterprise architecture a bad name in many circles. It's seen as the Department of No, the place where innovative ideas go to die, buried under a mountain of compliance paperwork and 5-year roadmaps that are obsolete before the ink is dry. But this doesn't mean architecture itself is dead. Far from it. It means the role is undergoing a profound and necessary transformation. The enterprise architect is evolving from a gatekeeper to a gardener. Think about it. A gatekeeper stands at a single point, deciding who gets in and who stays out. It's a binary controlling function. A gardener, on the other hand, doesn't control the growth of a single plant. Instead, they cultivate an entire ecosystem. They enrich the soil, ensure there's enough sunlight and water, build trellises for support, and pull the weeds that threaten the health of the whole garden. They create the conditions for success, enabling 100 different flowers to bloom in their own way, all while contributing to the beauty and health of the entire landscape. This is the future of enterprise architecture. It's about creating a fertile environment for technology and business to thrive together. It's less about dictating specific solutions and more about curating choices and providing paved roads. Instead of saying, "You must use this specific database," the modern EA says, "Here are 3 supported, secure, and cost-effective database options that align with our strategy. Here's a platform that lets you provision any of them in minutes, with monitoring and security already built in. If you choose one of these, you're on a golden path, and your journey to production will be fast and smooth. If you need something else, let's talk. But understand the trade-offs in support, cost, and security you'll be taking on." This new model is often called a federated or decentralized architecture practice. Instead of one central team, architectural competency is distributed throughout the organization. Architects are embedded within product teams, agile release trains, or business units. They are not outsiders, they are partners. They sit in the same planning meetings. They feel the same pressure to deliver. Their job is to be the local guide who also has a map of the entire region. They help their team make smart local decisions that don't create negative downstream consequences for the rest of the company. They act as sensors, feeding information back to a small central core team whose job is no longer to approve every project, but to spot patterns, identify cross-cutting concerns, and adjust the overall gardening strategy for the enterprise. To make this work, enterprise architecture itself must be treated as a product. Its customers are the developers, the product managers, and the engineers building things every day. And like any good product, it must solve their problems and be a joy to use. The product of EA is no longer a 200-page document stored on a forgotten SharePoint site. The product is a world-class developer portal. It's a library of well-documented, reusable APIs. It's a self-service cloud platform that makes compliance and security the path of least resistance. It's a set of clear, concise principles and guardrails that empower teams, rather than restrict them. When EA is a product, its success isn't measured by compliance. It's measured by adoption and customer satisfaction. Are development teams willingly using the platforms and patterns EA provides? If not, the product isn't good enough. This shift aligns perfectly with the rise of platform engineering. The EA team of the future sets the vision and the what, the strategic capabilities the business needs, the high-level guardrails. The platform engineering team builds the how, the internal developer platform that makes it incredibly easy for hundreds of development teams to build, ship, and run software that adheres to those guardrails. Enterprise architecture defines the city plan, the zoning laws, the major highways, the utility grids. Platform engineering builds the roads, the power lines, and the water mains that make it simple for developers to build great houses in the right zones. And what about the architect's toolkit? It's also getting a massive upgrade, powered by artificial intelligence. Imagine an AI co-pilot for the enterprise architect, an AI that can scan every line of code in the organization, automatically generating real-time, always up-to-date architecture diagrams. No more manual drawing in Visio. Imagine an AI that can detect architectural drift, alerting you the moment a service starts violating a defined principle, or a team introduces a new technology that isn't on the approved tech radar. An AI that can analyze cloud spending and system performance, proactively suggesting optimizations to save millions of dollars or improve customer experience. This isn't science fiction. These tools are emerging right now. AI won't replace the enterprise architect. It will supercharge them. It will automate the tedious, manual work of documentation and analysis, freeing up architects to focus on the highest value work: strategy, collaboration, and innovation. Ultimately, this all points to one critical evolution: the rise of the business outcome-focused architect. The most valuable architects of the next decade won't be the ones who can argue the finer points of Kubernetes versus serverless. They will be the ones who can sit down with the chief financial officer and explain, in clear business terms, how a shift to a composable architecture will increase market responsiveness and reduce operational costs by 20%. They will be the ones who can work with the head of sales to design a system that reduces quote-to-cash time from weeks to hours. They are translators, moving fluidly between the language of business strategy and the language of technology implementation. Their success is not measured in technology artifacts, but in tangible business results: revenue growth, customer satisfaction, and speed to market. So what does it take to become this architect of the future? The skill set is T-shaped. The deep vertical bar is still technical excellence. You must have a credible, deep understanding of how modern systems are built. But the horizontal bar, the thing that makes you truly effective, is now much wider. It includes business acumen, the ability to read a balance sheet and understand a business model. It includes exceptional communication and storytelling skills, the power to articulate a complex technical vision in a way that inspires a non-technical executive. It includes influence without authority, the diplomatic skill to build consensus among teams who don't report to you. It's about being a systems thinker, a coach, a strategist, and a diplomat all rolled into one. As we conclude this journey through the world of enterprise architecture, let's step back and look at the whole picture. We started by defining it not as a role, but as a discipline, the strategic practice of aligning business vision with technology execution. We explored the frameworks like TOGAF and Zachman not as rigid rules but as toolkits for structured thinking. We dissected the domains: business, data, application, and technology, understanding how they fit together to form a holistic view of the enterprise. We saw how architects work, using viewpoints and models to communicate with different stakeholders. We uncovered the immense value it delivers, from cost savings and risk reduction to enabling agility and innovation. And now we see its future. A future where architecture is not a centralized bottleneck, but a distributed, enabling capability. Where architects are not gatekeepers but gardeners. Where their product isn't a document but a platform. Where their focus is not on technology for technology's sake, but on driving measurable business outcomes. Enterprise architecture, in its most evolved form, is the ultimate connective tissue of the modern digital organization. It is the discipline that ensures the grand promises made in the boardroom can actually be delivered by the engineers at their keyboards. It's what transforms a scattered collection of projects and systems into a coherent, powerful engine for value creation. It is not an outdated relic. It is a strategic imperative. And in an age of constant disruption, the ability to design, guide, and evolve the enterprise as a whole has never been more critical. It is, quite simply, the art and science of building the future.